Hey there, physics people. I have a vector addition question for you for your viewing enjoyment. And this is the 13th one off of the packet that you have, where I decided to create another vector problem for you to solve. So what I've done here is I've solved the majority of it, and we're just going to have a discussion about it, mainly because the logistics of working this out on the computer takes a little time, and I think we can learn right nicely this way. What I've done here is I've drawn a picture that is more or less in the right quadrant, not perfectly to scale. I didn't measure things on the computer screen. However, it looks as you should end up with a picture if you've measured it out and drawn it to scale, with the appropriate angles where they are supposed to be. And of course, I have my different vectors labeled with their magnitudes of 4.7, 3.3, and 4.9. And the R, which is the dotted line, is our ultimate goal, both the magnitude and direction of that R. Of course, this picture is required, and it should match what your mathematics end up being. So what I have is a picture here, and then I've actually gone about drawing some other vectors on separate situations like I did in class so that we can look at them and analyze them for our SOHCAHTOA. So if we look at the first vector with the 4.7 magnitude and 50 degrees, that is west of north, we should have something that looks like so. And so I've created a right triangle, and I've used my 4.7. And if you take a look here, my x is opposite the 4.7, which is the hypotenuse. And since the x is opposite the hypotenuse, which is here, of course, then that means that I'm going to use sine. And I solve for my x here. And by doing so, I get 3.6. Notice how I've made the 3.6 negative. I did so because it's going in the left of the negative x direction. On the other hand, with the y, it was the adjacent of the hypotenuse. Therefore, I used cosine, and it was in fact going upwards, so that's a positive y direction. And when I did the cosine of 50 times 4.7, I got 3.02. So I've taken my first vector and I've broken it up into its components. And this is our x1 and our y1 if we go in order. The second vector is actually a pretty simple one because it's directly east. And since it's directly east, it has a 0y, and the entire magnitude contributes to the x, and the x is positive because it's in the positive x direction. So we don't need to do much SOHCAHTOA on this particular example. And so really what we end up with is an x2 that equals 3.3 centimeters and a y2 that's 0. The third vector is 17 degrees, that's north of east. So I have this drawn off of the east direction, and then I went up 17 degrees from there, and it has a magnitude of 4.9. You will notice that my opposite of this is the y, and the adjacent is the x. And since the adjacent is the x, I'm going to use cosine to solve for my answer. It's in the positive direction, therefore the 4.69 is a positive value. It's going up in terms of my y, and since it's going up in terms of my y, this 1.43 is also positive. And so this gets me my, well, x3 and y3 components. And so what I've got here are my three different components. My x1s with a vector drawn, my x2 and y2, my x3 and y3. Now I'm going to create another set of vertices just so I can do this in my head and make it look nice. And so what I've done here is I've taken my x1, 2, and 3, I've added them together to get a final rx and a final ry. And I've added all three of each of them, making sure that I have each value sign specific. If they're negative, that's very important because that either augments or cancels out different directions for our vectors. We then take the rx and ry, and I've plotted them in the x and y direction according to their appropriate direction. I then did the Pythagorean theorem here, and that allowed me to find the magnitude, which was 6.3, by doing a squared plus b squared equals c after I take the radical. To find the direction, notice how I went both east and then north, and therefore the angle I'm looking for is this one here, right? There's my theta. And therefore, that means that I am going north of the eastward direction. And that's why my 45.3 degrees is north of east. Now, the reason I reported it as 45 as my final answer, and my final answer is in this sort of box I'm making, that final answer is due to the fact that there are only two significant figures. In reality, there's one in the problem, but we're not going to get quite so tricky at this stage. We're going to limit this to 2, and the answer would be 6.3 centimeters, 45 degrees east of north. Well, if all is good in the land of physics, then this line here, of course, should be the 6.3 centimeters. And if you measure the angle, it should be right about 45 degrees, and that's going to be north of east. And you measure it up, it should look right nice. Hope you enjoyed. Thanks for watching.